Find the fifth term and the nth term of the geometric series whose initial term a1 and common ratio r are given. This is great. We've got the first term and we've got the common ratio, and therefore we can now write the nth term using the formula that we learned about from the first page, or it's also on your formula sheet. It says take the first term times r to the n minus 1 value. Okay, so we're going to write this as negative 2 times 4 to the n minus 1. This is my nth term formula. You cannot multiply the negative 2 and the 4 because of the order of operations. So you have to leave it just like that. The next thing you're told to do in the instructions is find the fifth term. All right, find the fifth term. That means A5. The fifth term is negative 2 times 4 to the 5 minus 1, and that's negative 2 times 4 to the fourth, which is negative 2 times, let's see, 256, I think. 512? Negative 512, I do believe. So that would be the fifth term. Number 28, find the indicated term of this geometric series, the eighth term of the series that goes 1, 3, 9, and then so on and so forth. All right, the first term is obviously 1 because I can see it. The common ratio, right? You were told this is geometric, so there's no need to determine if it is. We already know that it is. Therefore, it has a common ratio. How much do you multiply one term by to get to the next term? And that is going to be 3. And so in general, the nth term is the first term times r to the n minus 1, or how about 1 times 3 to the n minus 1, or how about just that, okay? We're going to use this formula to get to the eighth term, right? So 8 is not too far down the line. You could go ahead and keep multiplying by 3's, but we'll use the formula since we found it. The eighth term is 3 to the 8 minus 1, which is 3 to the 7th, which is beyond my knowledge. 3 to the 7th equals 2,187. These terms grow very quickly, don't they? Number 34, find the nth term of this geometric sequence. And so you're told that the first term equals 5. And since it's geometric, we know that we're multiplying by a common ratio to get from one term to the next. 5 times 2 equals 10. 10 times 2 equals 20. Keep multiplying by 2. The common ratio is 2. So the nth term, once again, a1 times r to the n minus 1, looks like 5 times 2 to the n minus 1. And we're going to leave it like that. You cannot multiply the 5 and the 2 because of the order of operations. That's all we had to do. Find the nth term. Did it. 44. Find the sum. All right, now we're going to add them up. And we are going to, let's see, write down the formula. Let's start there. The formula for the sum of n terms is equal to a1 times 1 minus r to the n over 1 minus r. Okay, so do we know the first term? Not really. Do we know n? No. Do we know r? Not really. So we're going to start this by writing out the first few terms. The first term, the second term, the third term. So the first term is where we want to let k equal 1. So that's 4 times 3 to the 1 minus 1, which is 4 times 3 to the 0, which is 4. The second term is where we let k equal 2. So that's 4 times 3 to the 2 minus 1, and that's 4 times 3 to the first, and that's 12. So remember how this is a sum? I'm going to start making these into sums. The third term, let's go one more, and then I think we'll see the pattern. The third term is where we let k equal 3. So 4 times 3 to the 3 minus 1, or how about 4 times 3 to the second, or how about 4 times 9, or how about 36? So we just determined that the first term is equal to 4. Okay, and now we can look at the terms from 4 to 12. What is the common ratio? 4 times 3 equals 12. And then from 12 to 36, does that still work? Yes, the common ratio is equal to 3. Common ratio is equal to 3. And so now I've got enough information to figure out the formula for my sum of n terms. So this is going to be 4 times 1 minus 3 to the n divided by 1 minus 3. I can simplify this a little bit. 1 minus 3 equals negative 2. 4 divided by negative 2 is negative 2. So I'm going to write this as negative 2 times 1 minus 3 to the n.